Okay, my friend, let's talk about different syntheses of alkanes. So, in previous session, we talked about Worth's reaction. Worth was a German scientist that proposed synthesis of alkane through a reaction of alkyl halide with sodium, lithium, or zinc that can produce. Actually, in Worth's reaction, the equivalent of alkyl halide should be equal with equivalent of metal, and an alkane, which is coupling reaction, can be produced RR along with sodium halide salt. And in this reaction, you can imagine that two radical have been reacted to each other in order to synthesize alkane product. So a coupling has been um, carried out in this reaction, and an alkane has been produced in this reaction, as you can see. But my friends, in this reaction, the alkyl halide is just one type. We only have one type of alkyl halide, so our alkane is symmetric. But what about asymmetric alkanes? This is what is where we are going to talk about problems of Worth's reaction. My friends, until now, all of our alkanes were only one type. We only have had one type of alkane. So our product was a symmetric kind of alkane. Two R have been connected to each other. So we only have had one type of R, or one type of alkyl halide, one type of alkane have been produced in these reactions. Okay, so what happens if we will have different types of alkyl halide that can react in with sodium? You can imagine, my friends, you will have a balloon, and you will have two types of alkyl halide, for example, Rx and R prime X, that can react with sodium in our balloon and with sodium metal. Okay, what happens? Wow, we will have mixture of products, because we remember that just couple alkyl together. So we will have R, and we will have R prime, R prime, and we will have R prime too. So basically, and along with salt. So basically, my friends, this is a mixture of products, because here in starting material, alkyl halide were just not only one type of alkyl halide. Here we had two types of alkyl halide. So in products, we have had three products. So this is the problems of this reaction. What are the problems of reaction? First of all, we will have mixture of products, mixture of alkyl halide with lots of um, problems for their separation, because these products are have lots of similarity in physical and chemical properties too. So the first issue, the first problem is mixture of products. It is not at all favorable in chemistry, in industry, and making money, my friends. Remember that. And the second problem is it's not at all selective. So when you will have mixture of products, so your reaction is not at all selective, and it's one important issue of this reaction. And also we will have problems for separation of products. It's very clear, my friends. Here we will have problems for separation of products. Yes. So basically, because as I mentioned, their physical and chemical features are similar to each other, alkanes. So basically, you can imagine, for example, we will have lots of different gas, because most of alkane are in gas phase. Some of them are in gas phase. So how difficult can be, especially through conventional way, you can for example, separate different alkanes. So we want to solve these problems. All of scientists think about this issue and they can propose another way in order to solve these problems, how we can synthesize asymmetric alkanes. So who came? Gilman. Gilman was a scientist that came approach and told, I will have another way of synthesis of alkane in order to solve this issue. And what Gilman told us? Gilman told us, let's react one alkyl halide with two equivalent of lithium, and we will have our lithium or alkyl lithium along with lithium halide salt or lithium X. So, my friends, we will have here a metal halogen exchange. What I mean is metal halogen exchange. You can imagine lithium in alkyl halide has lithium instead of halide, lithium is in your product. So lithium and halide has been exchanged and lithium has been substituted in alkyl halide. So X will go for lithium and other lithium will go instead of X in alkyl halide. It's very easy, my friend. Just take a look at the easiest way in order to predict what is the reaction of this product. Just instead of X, which is halide, put your metal. Which is metal here, my friend? Lithium. So instead of X or halide, put lithium. So it is R lithium plus lithium X. So after that, we add copper halide to alkyl lithium. So alkyl lithium we react with copper halide. So R2Cu lithium or diorganocopper lithium will be produced, which is Gilman reagent. It is Gilman reagent. Okay, so it is very important product, and when, my friends, I have told you we will have one alkyl that have been connected to metal or it is next to metal, this alkyl will be carboanion, and this alkyl will be negative, and this alkyl will be nucleophile. It is very easy that in R2C lithium we will have R negative or carboanion, and R negative or our carboanion has been stabled by metal. What I mean is because we know all of the metals, all of elements would want to be in especially for example elements such as carbon wants to be in there is wants do not want to have any charge. So by giving charge to that, it will become a little unstable. So by coupling to copper, this reagent will be more stable. Okay, I will explain about all of that later. So after that, we will have R2C lithium because of hyperconjugation between n uh, orbital of alkyl with empty orbital of d in metal. But later I will explain it. Okay, what happens, my friend? In here, we will have R negative that will attack to alkyl halide. R negative or our carboanion will attack to R prime X, our substrate. R negative will attack from back of alkyl halide, and our leaving group, which is halide, will leave alkyl halide from front of that. So finally, my friends, we will have an asymmetric alkane, which is R prime along with RCU along with lithium X. And RCU here is another product of this reaction, which also can react to R prime X again, and we will have this cycle again. So let's save it. Okay, so you found in Gilman reaction we will have we will can we will be able to produce R2Cu lithium, and it will be a nucleophile that can attack to R prime X, and it can synthesize an asymmetric alkane. Okay, so let's see what happened. Let's take a look at the mechanism of this reaction. As I mentioned before, my friends, I will tell you about all of details of reactions. So let's take a look at again to Gilman reaction. So in Gilman reaction, we will have one alkyl halide that will react with two equivalent of lithium, and in products we will have our lithium along with lithium X. And as I mentioned before, here we will have metal halogen exchange. It means that halogen will go to the place that we will have halide, and lithium will go, metal will go to the place we will have halide. So you can imagine we will have lithium and X, which is halide. So lithium will go instead of X, which is halogen. So we will have this exchange. Instead of X, you just write down lithium. That's the product. And because we will have two lithium, the other one will be lithium X. And it is very important, metal halogen exchange. So it is a general rule. So, my friends, what is the mechanism of this reaction? Zahra promised us to tell the mechanism. Okay, so we will have an alkyl halide, and also we will have lithium, and lithium is from group 1 alkali metals. That lithium has one valence electron. So basically, it will attack to Rx, and we will have a transition state which is both anion and radical. And also in this transition state we will have a homolysis disconnection. So R will take its own electron and it becomes radical, and halide, because has one electron from lithium and it will take one electron from this connection, would become negative or anion. So we will have lithium X salt. Okay, again we will have one R radical, and also we will have lithium. Lithium is our metal, so wants to lose one electron in order to become cation. So again, because there are two electrons in R, which is our alkyl, it becomes negative. And when you have one carbon that it has negative charge, it will be called carboanion, and the metal here is cation. So we will have lithium carboanion. And I have told you, Zahra told you, my friends, when you will have one alkyl that has been connected to that is in you will have a compound which is an organometal compound, alkyl next to metal. That alkyl will be negative because metals are electropositive, and you can see the mechanism that what happened, that lithium here became a cation, and we will have also carboanion. Carboanion or R negative is nucleophile, and it can attack to different reagents. Okay, we want to synthesize alkane. So what happens here, my friends? In here we can add CuX or copper halide to our lithium, and after adding CuX or copper, for example, halide, any kinds of halide, you will have R2Cu lithium or diorganocopper lithium. So R2Cu lithium, very easy, R2Cu lithium. What is this? Sahra told you, my friends. This is Gilman reagent. That's right. This is Gilman reagent. So what is Gilman reagent? Close your eyes and repeat with me. R2Cu lithium. And what is important in R2Cu lithium? R here is negative. R here is carboanion. R here can be nucleophile. R here can attack two different substrates such as alkyl halide. Okay, so we understood everything about that. Here we have dimer of in actually R2C lithium. We will have organocopper lithium. So we will have two equivalent of um, R or what is called alkyl group. And in a solution, when we will have a solution, we will have dimer of R2C lithium. So we will have dimer of Gilman reagent. And I will draw what happens to this reagent when it becomes dimer. So again, my friends, do not forget this is one important reagent. We will have lots of dealing with it in future. And the charge of R or alkyl here will be negative, and it will be carboanion, and it will be nucleophile, and it can attack to different substrate. And Zahra always tell, and also remember, copper here has one positive charge, the lithium here has one positive charge, and R or alkyl has two negative charge. Two alkyl, two negative plus two positive, they will naturalize each other charges. Okay, I'm going to draw the dimer of Gilman reagent. Remember, two equivalent of R2C lithium or dimer of R2C lithium. So two alkyl have been connected to Cu, and also we will have in another dimension lithium that has been connected to two alkyl. Okay, again, one copper in and that is between two alkyls, and again we will have two alkyl that have been connected to each other through one lithium. That's right, my friends. We will have one lithium here. Very easy. Very easy. Okay, all of these different items have been connected to each other. So this is the dimer of Gilman reagent in solutions. So it is a very good idea that you can draw this at home. R2C lithium dimer. Very important. In solution, this happens. Dimerization of R2C lithium will happen in solution. So I told everything about Gilman reagent. You never forget it, my friends, if you watch it many times. Okay, we found it, Zahra. We will have R2C lithium. And what else? We should have one substrate, R prime X. This is the thing that makes our alkanes. So, sorry, let's correct it. An eraser I need. Okay, so R prime X. And here we will have R prime along with R copper with lithium X. So our alkane is asymmetric. We have solved the problem of other reactions. We have solved the problem of worse reaction. Now we can synthesize an asymmetric alkane without any problems. Okay, so here what happens? R2C lithium. Zahra told us here R2 has negative charge. Here R2 has is carboanion. So here R is nucleophile, so it can attack to R prime X through SN2 mechanism that I will explain you later from back of substrate, and halide will leave as living group from front of this substrate, and we will have a coupling of R prime. Here we will have R negative, or our nucleophile will be R negative, or uh, carboanion that will attack from the back of R prime X, and our living group will leave a substrate from front of that. So we will have our R prime along with our Cu that also is can attack to other substrate. So here we could synthesize our R prime, and we reviewed the mechanism of Gilman reagent, Gilman reaction, and we became completely understood that here in R2CU lithium we will have a nucleophile which is R negative in Gilman reagent, and it can attack to our R prime X. So through this way we could synthesize our R prime, and that's a very good idea to synthesize that. But my friend, here we will ask one question. We found it, but what is R prime here? What can be R prime? With what condition? What is R in Gilman reaction? With which condition? So let's save it and let's speak about the condition of R prime and R in Gilman reaction. Okay, so let's save it. That's right. That's right. Okay, so let's talk about the condition of Gilman reaction, the condition of the second way for synthesis of alkane, especially when our alkane is going to be asymmetric. So, Gilman reaction. Again, please write it down. Again, do not take a look at here. Write it down. We will have one equivalent of alkyl halide along with two equivalent of lithium. So we will have R lithium plus lithium X. That's metal halogen exchange. That's right. And then we will have copper halide, and again we will have R2CU lithium or Gilman reagent, which is a nucleophile. Here we have produced a nucleophile, or Gilman reagent, which has a nucleophile and carboanion, anion, which is R, and the charge of R here would be negative, and we will have one R prime X as a substrate, and here R will attack from the back of the substrate through mechanism SN2, and our leaving group will leave R prime X from front of that. So finally we will have R prime, which is a kind of coupling between R and R prime, RCU, along with lithium X. Okay, so here, my friends, we are going to review based on the reaction that I told you, the mechanism of Gilman reaction. As you can see, I have drawn the mechanism of attacking Gilman to our prime X, or our substrate. Okay, so let's talk about conditions. Gilman uh, reaction condition. Gilman condition. Gilman reaction condition. Okay, first of all, the solvent. Solvent in Gilman reaction should be aprotic, my friends, because here we will have carboanion, and that will attack to R prime X. And if we have, for example, protic solvents such as water, this carboanion will, for example, will get a proton of water or proton of alcohols, and it will become RH. So in order to avoid these problems in these types of reaction, especially, my friends, in SN2 mechanism that I will speak about it later, we definitely need aprotic solvents that hydrogen has not been connected directly to fluor, oxygen, nitrogen, and sulfur. So basically our solvent should be aprotic, that it's kind of solvent which is polar, but it is aprotic. Okay, the second, in Gilman reaction, aromatic halide also can participate in this kind of reaction. So we can involve aromatic halide in this type of reaction, in Gilman reaction. Okay, so what is the third condition? Actually, R prim X, which is our substrate at the final stage, um, is better to be methyl halide or if it is not methyl halide, the carbon in R prim X is better to be type 1. Carbon type 1 is preferred. So, because the rate of reaction also depends on the type of R prime, the type of carbon. We will have carbon type 1, and I will explain you right now. And if R prime would be, if the carbon of R prime would be carbon type 2, the rate of reaction would be slower. Okay, so the rate of the reaction if the carbon of R prime would be type 2 would be slower in comparison with carbon type 1, and methyl halide is the best R prime X. If R prime would be methyl is best, after that carbon type 1 would have the best rate, and the rate of reaction would be slower when the carbon would be type 2. Okay, here we will have this is methyl halide, and also this is the best condition. Also we can have um, uh, for example CH2 that has been connected, sorry, here let's put it okay, halide. Okay, just let's look at this carbon. This carbon has been connected with single bond to only one carbon. So if our carbon have been connected only to one carbon, to one another carbon, this type of carbon is carbon type 1. This is very clear, my friends. It is carbon type 1. So methyl halide or methyl is very easy, and also we will have carbon type 1. These are different from each other. Um, because I told this or means the best rate of reaction. First of all, this is methyl halide, and also after that, the best rate will go for carbon type 1 in Gilman reagent, because it is the best. Um, it will be the best for leaving our halide, and it is best for uh, attaching nucleophile to that. Okay, also we will have carbon type 2. In carbon type 2, two carbon has been connected to our, for example, CHX. As you can see, we will have two carbon that directly has been connected to our carbon. So here is type 2. For example, you can see we will have CHX. CX for example halide or something like that. You can see we will have methyl and ethyl. Both methyl and ethyl have carbon. Okay, so two alkyl groups or two carbon, it doesn't matter. For example, which group is 2 carbon has been connected to CHX. So this is type 2. So because, for example, here we will have one alkyl that has been connected to our CH2X, we will have type 1. And also in after that, we will have 2 carbon that has been connected to CHX, it will be type 2. And you know, my friends, the rate of reaction for carbon type 1 would be better than type 2. Why? Because when we will have one nucleophile, put yourself instead of our nucleophile, you want to attack somewhere. If there would be lots of strict hindrance and lots of repulsion in order to get approach to that substrate, you will have lots of problems. You should try more. So our nucleophile prefers the places which has less strict hindrance. Okay, so basically, and you should put yourself as an attacker, as a nucleophile, as someone who wants to attack somewhere. So when there is, for example, methyl halide, it is the best. Only 3 hydrogen. These are very small. They will have no strict hindrance, the best rate. After that, we will have carbon type 1. Only one carbon has been connected to our CH2X. So there will be less strict hindrance. So the rate of reaction would be better. But in carbon type 2, again, we will have this Gilman reaction, but the rate of the reaction will be slower because there are two, for example, alkyl groups, 2 carbon that has been connected to our CHX. So basically, more strict hindrance, more problems. So they irritate our nucleophile. Okay, so this is the different rules of Gilman reactions. So remember, R'(X) is better to be methyl halide, or after that carbon type 1, and after that carbon type 2. Um, that the rate for carbon type 2 is considerably slower, and I told you why. So let's save it and let's go to new document. Very easy. I told you from 0 to 100 about Gilman reactions. So do not forget, please, to subscribe. And if until now you are with me, please leave Gilman in comment box. Okay, so also, we talked about type 1 and type 2. Also, I wanted to talk about carbon type carbon, tertiary carbon, or carbon type 3. We call carbon type 1 primary, we call carbon type 2 secondary, and we call carbon type 3 tertiary. Also, we will have carbon type 4 that here I didn't spoke it, later I will explain. It is quartary. Okay, so again, 3 carbon has been connected to CX, or our carbon. You can see we will have 3 alkyl, 3 carbons. So it is carbon type 3, or tertiary carbon. Okay, so we understood everything about different types of carbon. So let's talk about example of Gilman reaction at the end of this session in order to understand what was Gilman reaction. Okay, but before that, let's again review in Gilman reaction, the rate of reaction is, actually I have not written methyl. First of all, it should be methyl, but anyway, generally type 1 or primary would be better than carbon type 2 or secondary, and it would be definitely more greater than type 3. We will not have type 3 in Gilman reaction, but anyway, if you want to talk about rate of reaction, it is definitely preferred to have carbon type 1 or primary carbon. Okay, so it's all about rate of reaction. Okay, so my friends, let's take an example. Without example, you cannot understand organic chemistry. That's right, my friend. So let's have ethyl chloride along with dimethyl copper lithium. Okay, so what is the product of that? You can write it down right now and you can guess the product. Very simple. Okay, I hope that you write down. So here, my friends, we have R2CU lithium. Zahra, what told us when you have R2CU lithium? This is Gilman reagent. In Gilman reagent, what is nucleophile? What is negative? What is carboanion? R2CU lithium. That's right. So is negative. Which is R here? Methyl is R here. So methyl is our nucleophile that can attack to our substrate. Which is our substrate? Ethyl chloride. That's right. So here methyl will attack to ethyl chloride from back of ethyl chloride, and chloride will leave ethyl from front of alkyl. From front of alkyl chloride or ethyl chloride. So we will have methyl, methylene, and methyl. So propane uh, will be our product. Propane is our product. Propane. That is an alkane with 3 carbon. Okay. Or C3H8. Okay, my friend, it was very easy mechanism with everything. But if you are someone who is very, very interested in synthesize, let's let's have retro synthesize of R2C lithium. This arrow means that this R2C lithium or this Gilman reagent have been produced from which starting material. So it is retro reaction. We will have R2C lithium has been uh, produced from methyl halide plus 2 equivalent of lithium plus copper halide. So let's start it from the first. For example, we will have methyl bromide with 2 equivalent of lithium. You do not have to write it down in your exam, but it is very good for practicing. And for example, you will have methyl lithium along with lithium bromide. Okay, so we will have methyl lithium in metal halogen exchange. So we will put one copper, for example, copper bromide or copper iodide. Um, can be used in order to synthesize Gilman reagent, which is dimethyl copper lithium. And this is Gilman reagent. Please write it down in order not to forget what kind of reaction you are talking about. So Gilman reagent, Zahra told us in Gilman reagent R2 is our carboanion and R2 is our nucleophile and R2 is one R with negative that can attack to our substrate. Okay, what also we will have? We will have our substrate. What is our substrate? Ethyl chloride, my friend. So yes, write it down. Here are methyl carboanion will attack from the back of ethyl chloride through SN2 mechanism that Zahra will tell you later, and chloride will leave a substrate from the front of that. So finally we will have one methyl that has been connected to ethyl. So this is propane and this is our product, and our other product is very simple, which is methyl copper along with lithium chloride. But it is not very important only writing down propane as our final product is enough. Okay, so let's talk about another example that may come in your exam, and let's save it. My friends, do you remember the second condition of Gilman reagent? I talked to you that aromatic halide can also react with, for example, Gilman reagents. So we can have phenyl iodide as R prime X here. So again, this is the question. Phenyl iodide has been reacted with dimethyl copper lithium in ether as an aprotic solvent. So what is the product of this reaction? Please write it down in your paper. Again, what is our Gilman reagent? R2 Cu lithium, which is dimethyl um, Cu copper lithium. So, what is here negative, my friends? Our negative is here is methyl. Our carboanion or our nucleophile would be methyl. Methyl with one negative charge. Will be our nucleophile. And what is here? Substrate, my friends. The substrate here will be phenyl iodide. But the mechanism of here have been written in some books that here the mechanism is radical in this type of reaction. But here I just do not want to talk about the details of that. Only if you had this reaction again instead of iodide, you should connect methyl to phenyl. But again, the mechanism of this reaction have been reported radical mechanism in some books. So I just do not want to distract your concentration. But again, if you had phenyl iodide, because iodide is one of the best living group, iodide is considerably greater than bromide or chloride in order to live phenyl, in order to live, for example, alkyl, no matter what. So because of that, iodide has been selected as our living group. And finally, we will have uh, toluene, which is toluene. Phenyl that has been connected to one methyl is toluene. So this is our product. I will talk about the details of this type of reaction later. Only it is important to know what happens here. So again, we will have R2Cu lithium, which is dimethyl copper lithium, and it has we will have retro reaction that it has been produced through methyl, for example, halide plus 2 equivalent of lithium plus copper halide. For example, methyl bromide can react with 2 equivalent of lithium, and we will have metal halogen exchange, my friend. Just put lithium instead of bromide. Very simple. Also, we will have one other lithium which can be cation, and we will have lithium bromide. So I should write instead of X bromide. No matter. Okay, so the solvent, as I mentioned here is ether. You can take two different sources in order to understand the mechanism of this type of reaction. So we will have copper iodide here. If you, my friends, it could not find the mechanism of this reaction, please leave in the comments that you could not find, and I will talk about the mechanism of that rate later. Okay, after adding copper iodide to methyl lithium, we will have dimethyl copper lithium, which is Gilman reagent. It will react with phenyl iodide, and we will have, instead of halide, you should put your nucleophile, which is methyl, my friends, here. Okay, so instead of phenyl, we put methyl. And also I have to talk about living group. Iodide is better than bromide, and bromide is better than chloride as living group. I will talk about details of living group later, but just right now, please know that iodide is the best between different halide as living group. And just because the connection of phenyl and iodide in connection of phenyl and iodide, because iodide is bigger in comparison with bromide and chloride. So the connection of phenyl and iodide uh, will be the connection of phenyl and iodide will be weaker in comparison with, for example, phenyl fluoride. And also, for example, in for example, phenyl chloride, this connection is too strong. The disconnection of them, for example, would be very harder. So please take a look at that. So finally, our product would be phenyl methyl, which is toluene. Okay, so our this is our final product, and I'm going to talk about our third example, which is cyclohexyl bromide. This is our final example that we will have. Okay, one, two equivalent of lithium, and then copper iodide, and third reagent would be methyl iodide. When they say 1, 2, 3, it means the first stage would be 2 equivalent of lithium, the second stage would be copper iodide, and the third section would be methyl iodide. Okay, so this is a reaction with 3 stage, my friends. That's right. So what happens here? We will have bromocyclohexane, and after reacting with 2 equivalent of lithium, we will have lithium cyclohexane and lithium bromide. And again, this will react with copper iodide and will be produce cyclohexyl copper lithium. This is our R2CU lithium, or di organo copper lithium, and this is our Gilman reagent. My friends, which is here nucleophile R2, which is R2 cyclohexyl. So our cyclohexyl will be our nucleophile, and it can attack to what? Methyl iodide. Methyl iodide will be added at the third stage. So basically, cyclohexyl will, which is our carboanion, will attack to methyl iodide from the back of methyl iodide, and iodide will leave methyl from the front of that this substrate. So finally, we will have uh, methyl cyclohexane along with other product, which is cyclohexyl copper with lithium iodide. But the most important product here is, you should write it down, uh, methyl cyclohexane. This is our product, methyl cyclohexane. This is our product. Okay, so finally we could understand in this type of Gilman reagent what is how we can produce alkane. Thank you that still now you have been with me, and this is the end of this session. Thank you very much, and please repeat it at home.